Dear students, today I am going to discuss a square and square roots and its properties. So, property number one, first. First, no perfect square will end with 2, 3, 7, or 8 at the units place. For example, 33, 217, 738, 26,537, etc. are not perfect squares. Okay, here ending with 3, ending with 7, ending with 8. So these are not perfect squares. Second point of property 1 is a number having 0, 1, 4, 5, 6, 9 in the units place may or may not be a perfect square. For example, 81, 484, 1225, etc. are perfect squares. But 91, 246, 924, 1900, etc. are not perfect squares. Property 2. First point. If a number has 1 or 9 in the units place, then its square will end with 1. Example, we can take 11 square is 121, 9 square is 81. So in the units place 1 you have. Second point of property 2 is the square of a number which has 4 or 6 in the units place will end in 6. For example, 4 to the whole square is 16. Units place 6 is there. 6 to the whole square 36. 6 is in the units place. Now third point of property 2 is if a number has 2 or 8 in the units place, then its square ends with 4. Example, 12 square equals to 144. In 12 you find in the units place 2 is there. So its square we have 144, which unit place is 4. 18 square here unit place is 8 and 18 square we have 324, in which 4 is in the units place. So in both places you find unit place 4 is there according to this rule. Fourth point of property 2 is if a number has 3 or 7 in the units place, then the square of that number will end with 9. Example, 33 to the whole square. Here you find 3 is the unit place. So 33 to the whole square equals to 1089 and its unit place is 9. 47 to the whole square, here unit place is 7 and 47 to the whole square equals to 2209, in which unit place is 9. So in both the places unit place we have 9. Okay. Now fifth point of property 2 is the square of a number which has 5 in the units place will end in 5. Example, 25 to the whole square equals to 625. So here in the unit place 5 and its square has also in the unit place 5. 65 to the whole square equals to 4225. In 65, 5 is in the unit place and its square has also 5 in the unit place. So both places 5 we have in the unit place. Now property 3. A number ending in an odd number of zeros is never a perfect square. Example 4000. Here you find number of zeros 3, which is odd. 100,000. Number of zeros 5, that is odd. So 4000 is not a perfect square. 100,000 is also not a perfect square because number of zeros are odd. Now property 4 is between the squares of the numbers n and n plus 1 there are 2n non-perfect square numbers. For example, square numbers are 1 square, 2 square, 3 square, 4 square and so on, etc. So you find first between 1 square and 2 square there are 2 into 1 according to this rule 2n. Here n is 1. Yes, and this is n plus 1. So 2 into 1 that is 2n equals to 2 non-perfect square numbers are there, that is 2 and 3. Now second example, between 4 square which is n square and 5 square which is n plus 1 to the whole square. So here n is 4. There are 2 into 4 that is according to 2n equals to 8 non-perfect square numbers. Namely, those 8 non-perfect square numbers are 17, 18, 19, 20, 21, 22, 23 and 24. All these are lying between 16 and 25. So between 16 and 25 there are 8 non-perfect square numbers. In the same way, between 6 square and 7 square, where 6 square is representing n square and 7 square represents n plus 1 to the whole square, that means n is 6. There are 2 into 6, that is 12 non-perfect square numbers. That means between 36 and 49 there are 12 non-perfect square numbers. Yes, and those are 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47 and 48. That means between 36 and 49 all are non-perfect square numbers. In this way, we are finding number of non-perfect squares between two consecutive squares. Okay, thank you. If you like, please share and subscribe.